Okay, so I just wanted to do a quick video on the display that I have built for my Destrat system for destratifying the hot water cylinder. Now that it's powered by solar panels and diverting the excess electricity that would otherwise go to the grid, directing that to the immersion heater in the hot water cylinder and using that to heat it up, rather than using the gas central heating that we'd normally use. So this is the setup, which I hope you can see properly. Basically this screen is divided into three areas. On the left is a graphic depiction of the cylinder itself, hot at the top and cold at the bottom. On the right hand top over here there are two dials. One represents the speed of the destratification pump. There's a 12 volt, fairly small pump that is driven via pulse width modulation signal and moves water from the top of the tank to the bottom in order to stir it up and destratify it. On the right is a boiler signal. Again, this is a demand signal for heating from the gas boiler as and when needed in the winter primarily. This is normally switched off via a manual disconnect switch. This is a switch that is elsewhere, but when the switch is on, this unit controls it via a simple relay that's connected into the existing boiler control system. Finally, down here is a graphic, or a graph indeed, of the history of the status of the hot water cylinder. So this runs from the current time at the right hand end here to 8 hours, in fact 8 hours, 8 1/3 hours in the past. So there's 4 hours here, if you can read that, and 8 hours here. This is 200 pixels wide, so each pixel is 2.5 minutes basically. So every 2.5 minutes a column is added on the right hand side and a column is pushed off the left hand side. So you're constantly seeing the last 8 and a bit hours and what the current status of the tank is. So looking at each of those in turn, going back to the cylinder, so this is just a graphic representation of the cylinder itself. There are 5 temperature sensors. They're all Dallas serial sensors connected to the microcontroller Arduino. There's 3 on the cylinder itself, one glued to the top, one glued on the middle, and one glued at the bottom. So these are the 3 temperatures, and of course it's stratifying. To some extent it's hotter at the top than it is at the bottom, which is why the pump's necessary. There's also, because the pack came with 5 transducers in it, I used the extra 2, one on the outlet pipe, the hot water feed to the taps and the rest of the house, and this one down here, this little flag here, is the heating coil from the boiler. So if the boiler is on and heating the water, then this temperature will rise. And there's little spots along here, which you probably can't see, that represent the coil. They change colour with that temperature. So all the temperatures work on the same colour scheme, red for hot, blue for cold, and it automatically the code that I wrote assigns a colour pixel by pixel depending on the temperature at that point. It actually interpolates between these 3 known temperatures. As you can see, the display is failing. There's some vertical rows here that have failed, so I need to replace this display. I've got another one to fit, but I just haven't got around to it yet. This display updates when the temperature changes, so the code simply adds up the 5 temperatures, and if the sum of all those temperatures changes by, I think it's ½ degree, then it will update the whole thing. So it doesn't refresh every few seconds, it waits until something has changed and then it refreshes that display. Okay, so on the right hand top, so the pump display is a pseudo analog display, just indicates the speed being called for from the pump. Essentially the pump is run so as to try and keep this top temperature at 60 degrees centigrade or less. So if it goes above 6 degrees, then this pump will kick in and start to move hot water from the top to the bottom of the cylinder. thereby evening the temperatures out and dropping this temperature down. Notice it's above 64 now, but I'll come back to that later. So as the pump starts up, so it's actually a non-linear relationship between the pump speed and the error in the temperature. But as the error gets greater, the pump will speed up and try and get it back down to the set point. Incidentally, when I'll come back to that, this one here is the boiler demand. This works on a sort of it's a macro PWM pulse width modulation arrangement, which I stole from somebody on the internet. Essentially, so this is just operating a relay on the existing boiler circuit. So you don't want it to be banging on and off too often. So the way this works, there's a 10-minute window, which is represented by this dial on the green inner side. So each of these gradations is 1 minute, so 0 to 10 minutes. So every 10 minutes this green band will rotate round, and that represents one of the say macro pulse width modulation cycles, if you like. It's not demanding any heating from the boiler now, so it's 0. But if the level of temperature in the cylinder had fallen below a certain level, it would start to demand boiler input, and a red display between the green and the outer would start to appear to indicate how many percent of boiler was being called for, up to 100% obviously if the cylinder is really cold. So 100% the boiler will just come on and stay on permanently until such time as the temperatures rise and this demand starts to back off. As it backs off, say it got round to 50%, then during that 10-minute window, the boiler would come on for 5 minutes and then stay off for 5 minutes, then come on for 5 minutes and off for 5 minutes as this green counter cycles round. And obviously that would start to heat the water, and so the set point would start to fall below 50% down to 25, say, and so on. It never goes below 20%. There's a fixed stop, as it were, in the software that doesn't allow anything less than 20%. So the boiler, if it's just trying to top up the cylinder to full temperature, then it will come on at 0 minutes at the start of a 10-minute window. It'll stay on for 2 minutes and then go off again, wait for 8 minutes, then come back on again for 2 minutes, and so on, until the set point is reached, and then it'll drop straight to 0 and stop all boiler activity. So that's that. Down to the graph, as I say, each vertical pixel column is 2.5 minutes apart. So it shows the history over the last 8 hours of what's been going on in the cylinder. The yellow and green, there is a red option as well further down, but the yellow and green represent the energy stored in the cylinder, or at least an estimate of it. So there's a calculation that uses the 3 temperatures and the specific heat of water and some other sort of assumptions to work out the energy that's been stored in the boiler. And that goes from 0 to 100%, of course. There's a fixed 100% level, which is relatively arbitrary, but I think mine set at about 8 kilowatts using the function that I'm using. But that basically represents a full cylinder pretty much. The set point for the boiler is actually 75% on this scale. 75% represents a good bath. Basically, you can draw a full bath of water and have a comfortable bath at a nice temperature, so long as you've got 75% in the cylinder. And actually 75% is where we change from yellow to green. So we reached that point today. Time now is about 4:30. So we reached that back in the morning, 6.5 hours ago. So what was that, about 10 o'clock or something? 10:30, say. So yeah. So in the winter, when there's no sun, the boiler would heat the water to 75% and then just stop and maintain it there. And that's fine most of the time. In the summer, we get a bit of a bonus, we get some extra hot water. Also on this graph, there's, we see the percentage calibration down this side, that's for the total energy. Obviously the live energy is displayed down there. That actually moves around depending on where the graph is, either down there in black or it's up here in white, depending on where the graph is. On this side there's the temperatures, and there are three lines on here. There's a red, a blue and a white. Well, red, white and blue. Red is the top temperature up here, the history of it, and the middle temperature is the white and the bottom temperature is the blue. So you can see how the top temperature came up to 60 quite early this morning and has stayed there because that's what the pump is doing. The pump is controlling on holding it at 6 degrees C. Meanwhile, these other temperatures have crept up during the day as the destratification has gone on, and we've reached the full tank situation that we're at now. This adds a new column every 2.5 minutes. This little indicator here just shows you where we are in that 2.5 minute cycle. So when that green gets round to the bottom again, it'll add a new column on here and just refresh the display. So as you glance at the display, that just tells you when it's next going to be refreshed. Fairly arbitrary. It will refresh in between those times, by the way. If this steps up or falls by an integer value, 102% now, then it'll automatically refresh the display. It doesn't add a column necessarily. It only does that as it's about to now, when that 2.5 minute timer trips out. But just to keep it live, there you go, there's a refresh of the display, and you might notice that the graph has moved slightly across from right to left. But say if this changes to 101, say, between these 2.5 minute updates, then it'll refresh the display just to change that value, but not to shift the graph. Finally, along the top edge of this, again just for interest really, there are little flags along this top edge of the graph, which you can hardly see normally, but they just indicate when the pump is run. If it's blue and white, those flags represent the pump running. So that'll be a 2.5 minute period during which the destratification pump was running. So it's run quite a few times today. It kicked in here nearly 8 hours ago, and it's kicked in and out periodically. It normally runs at a pretty low level, normally gets up to sort of 20%, 25% perhaps when it comes on. There's various timers in the background that stop it from coming on too often. It backs off for so many minutes. I think it's 3 or 5 minutes. So if it's been on once, it won't come on again until at least, I think maybe say 5 minutes has elapsed, in which case it'll re-enable the pump. So just stop it hunting continuously. So that's that. The other thing on this status line, there are red flags as well. Those are points where water has been drawn. Hot water has been drawn from the tank. So again, the software watches this temperature up here on the top left of the cylinder display. If that changes within a certain period of time, the software assumes that water is being drawn and sets that flag. So again, that's a 2.5 minute period during which water was drawn from a tap somewhere in the house. So if it's a significant amount of water, then you'll see the curve will drop and hopefully be refilled by the solar energy coming in. The reason this is at 102%, which sounds impossible, the way this works currently in the software, so it holds 60 degrees in terms of the destrat pump. When it gets to 100%, then it stops activating the destrat pump. So the temperature will just rise as more solar power comes in, and it'll exceed the 60 degrees. That's why this is up to 63, it was 64 minutes ago. About 65, it will trip the ordinary bimetallic thermostat in the immersion heater body. So, and obviously cut off power, so heating of the water stops at that point. But then it's floating above, strictly speaking, 100%, which is say where it is now, because it's the end of the day. So it'll just sit there. Periodically the bimetallic thermostat will click back on, which you can see happening here, for instance. So there's more heating, it rises again until the bimetallic switches off. So on a really hot day in summer, typically this will sit here just with the bimetallic strip flipping backwards and forwards for a number of hours during the day once everything's warmed up. So I think that's it. The Destrat button, by the way, if the water, well, yes, finally, just come back to me. The final thing probably is this little indicator here, which I added. This shows a blue triangle pointing downward arrow if the cylinder is cooling, and it shows a red upward arrow if the cylinder is warming. So basically the software uses the historic data it's got of the temperatures over time to work out whether the cylinder is warming up or cooling down, and it does an estimate at least of how many watts of power is being lost or gained. So as you can see, we're losing heat now, and you saw the temperature fall from 64 to 63, so it's hovering around full, but obviously overnight it would lose more temperature despite the insulation on the tank, or the cylinder rather. So when the software knows that the temperature is falling, then that inhibits the pump activity as well. Doesn't seem much point in destratifying anything so long as the cylinder is getting cooler overall. So that's a final piece of the jigsaw in the software. Okay, I think that's about it. Obviously, if there's any questions, by all means put them in the comments, but otherwise, thanks for watching.